Hi, welcome to Rest Assured Tutorials. In this tutorial, we are going to learn how static as well as non-static method works. Why we actually make a variable static, why we make a method static, right? And where do we actually use it? So all of this will be discussed in this session. Okay, so to understand this, we'll create a new class. I'll show you an example, and from that example, you'll get a good idea about that where and why do we make a method or a variable static. Okay, so I'm creating a new class here, and let's say I name this class as planet. Okay, now in this planet class I'm creating two variables. First one is, let's say, belongs to the string class, and let's say I'll give it name as name. Okay, for the planet name. And another variable I'm creating shape. Okay, these are my two variables. Now again I'll create main method right here, and in this main method I will basically initialize these variables or the string objects that I have created. Okay, so suppose I told you that in order to use any property of a class, we create its object in the main. So for the planet class, again I'm creating its object. So let's say planet, and I'm giving the object name as p1, initializing it. Okay, so the object is ready. Now using this object I can use this variable. Okay, but right here let's say I'll create one more object. Okay, p2, and I'll initialize this also. Okay, and let's say create one more. So right here what I'm doing is, within same class, this planet class, I created different objects for it, p1, p2, p3. Okay, now let's just think about this as this. Okay, suppose, okay, I'll just change the color. Suppose this is the object 1. Let me get a better background here. This is the p1. Okay, I have another object. Let's say this is p2 and this is the p3. I'll write down the names so you'll get a better understanding. p2 and p3. Okay, now each of these has its own name and shape variable. For p2 also name and shape. For p3 same, name and shape. These were the three variables, right, for the class, and for each of these objects there will be a different name and different shape variable. So we start giving it name. So I'll say p1 dot name equals to earth, right, and let's say p2 dot name equals to Jupiter. Okay, same goes for p3 dot name equals to, let's say, Pluto. Okay, so what we did now, we just gave these a name. So p1 name equals to earth. Okay, this is Jupiter and this is Pluto. Okay, this is what we did so far. Now same thing we'll do for the shape variable. Or before going to the shape, I'll tell you about some very small concept. If I print all of these to get it in the console, to see it in the console, what I'll do is I'll use a display statement. Say name of first planet is some name, right? So concatenate it with the p1 dot name. This is the name of first planet, so this will print the name of first planet. Same thing I'll do for the second planet object, and same thing I'll do for the third object, which is p2, p3, right? And this is your second object, this is the third one. So now if I run this program, I'm saying the name of first planet is Earth, name of second planet is Jupiter, name of third planet is Pluto. So all these are printing. But now if I do a very small thing here and I say, let's say P1 is equals to P2. So what will happen now? Before running this program, I'll show you the illustration again. Earlier it was like this. P1 was pointing towards this memory location, which has name stored as Earth and shape we didn't set yet. Here P2 is pointing towards name equals to Jupiter and P3 name equals to Pluto. Okay, but now when I'm writing P1 is equals to P2, that means P1 no longer is pointing towards this memory location. Okay, now P1 is start pointing towards the memory location where P2 is pointing. So now if I run this program again, okay, and check it out, these outputs again, you will see a change in the name of object P1. Okay, so earlier it was like this, but now name of first planet is also showing as Jupiter. Why? Because I said object P1 is equals to object P2. That means P1 is not pointing towards this memory location which was pointing earlier, but now it's pointing towards where P2 is pointing. Okay, okay, now if I'll talk about one thing more, one variable more that we have declared, which is shape. If I set the shape, again I will follow the same drill. What I'll do here is, again I'll say P1 dot shape equals to circle. Okay, P2 dot shape, again this planet is also circular in shape, so I'll say circle, and let's say P3 is also equals to circle, right? Same thing, I can print name of the first planet as this, and let's say again concatenate it. I'll say shape is just, again we have to add that variable, so I'll say P1 dot shape, and this is the same thing I'll do for the other variables too. Okay, so here I'll say P2, P3. You must be wondering, it doesn't make any difference if I'll still say P1 because all the shapes are similar. So that's the exact my point. That exactly is my point. If I run this, now you will see the shape is circle, shape is circle, shape is circle. So that means all of the these object has one different property and one similar property. Like all of these three objects have different names. That's why we created this different object. But this shape property is same among all these planet objects. Okay, so what we are doing right here, it's not correct. We are just wasting the memory space again, allocating the same thing to the same object. So how we can make this better? From the illustration itself, I'll show you again. So this is now it's happening, but the shape is same. So why don't we do something? This is a circle, this is also circle, and this one is also circle. So why don't we create a memory space such a way here that is shared among all of these. Okay, suppose this point towards this point towards this, and here I will store that value of that shape equals to circle. So all have the access to it. Okay, this is the right way of doing what we are doing right here. It's not correct because all this planet have same shape, so it's not a good practice to write the same code again and again. So I can do this by making this shape variable static. Just see when I'll make it static. Okay, I have no longer to give it p1.shape again and again. I can simply say here shape equals to circle. Okay, and I can directly use the shape when I'm printing the output. You see, I'm not getting any error. But if I don't make it static, this code won't work. We'll get an error. Cannot make a static reference to a non-static field. So whatever fields that we are created, this is the non-static one. When we create it static, it no longer require dependent on the object of the class. It's independent now. It's now dependent on the class itself, not on the object. So we can directly use it. So now if I'll run this, we'll see the same output. Okay, but this time we did it in the right way. Circle was a common property among all these planet class objects. Okay, so that's why I made it static. Okay, so this is why we create the static variable. Now we'll see how and why we create the static method. Okay, so we have just discussed how a static variable works, or when we make a variable static from this example. Now we'll discuss about static methods. Okay, so with this same example, if I create a function here, I already told you, how we create a function. So in this class, I'm creating a function called, let's say, public void print name. So basically it's going to print the planet's name according to its object, right? So I'll say system.out and I will print the name of the planet. Okay, via this function now. So here I'll just simply say name. Okay, and I will create another method here, public void, let's say revolve. It's another function of the planet class. I'm naming it as revolve. And this again I'm putting a display statement. Let's say planet is revolving, okay, around sun. Right, it's a simple function. Now both of these methods are non-static, right? Or just forget the name static. These are the normal function or the method that we are creating earlier. So in order to use this method, what we have to do is use the object, planet object. Let's say I'll use p1 and call its function. So the first function is name, print name, right? So I'll just simply use that function. For p1, for p2 also I'll use this function. Same goes for the p3. Okay, I'll comment out other things, so we'll just see this in the output. Okay, same I'll do for the other function. We have another function called revolve. So I call the revolve function with object p1, now with object p2, now with object p3. Okay, simple as that. Now if I run this class, in the output I'll see name of the planet, right? Earth, Jupiter, Pluto, and planet is revolving. Now the output of the second function that we have created, revolve, is similar for all the objects, or for all the planet class object, output is same. So again, why we made the state variable static, shape variable, because it was a common property. Now this is a common functionality. We created a function that is used by each object of this planet class, and it's again a common functionality. So why don't I make this as static? So now if I write static in front of it, there's no need to call this function 3 times, right? I can simply call the revolve without any object. I won't see any error. If I run this, I will see this in the output. I can call it multiple times, as many times as I want. Okay, so if I want to call revolve again, I can do that. Now it's not dependent on the object, right? It doesn't require any object for its execution. But instead, now if I remove the static in front of this method, now it requires the object. Say it's saying cannot make a static reference to a non-static method revolve. Okay, so now it requires object. So basically, whenever you make any variable static, any method static, it doesn't depend on its object of the class. It's independent. It can be directly used without any object reference. Okay, so that's the main difference among a static and a non-static method, that a static method for its execution requires an object, but a static method doesn't require that, but a non-static method requires that. Print name is a non-static method, that's why it requires an object for its execution, but revolve method is static, that's why it doesn't require any object. Okay, simple as the same thing for the variables like we have discussed. And again, if we talk about where are the static methods, so in the Java libraries itself there are so many methods that are static. Okay, there are pre-existing methods that are static. If we take an example, I'll show you the example of it. Okay, so now let's just see another example of a static function that is pre-existing. Within the REST assured itself, we are going to use so many methods that are present in REST assured library that are static. So let's see how we use those pre-existing static methods. So I'll create a new class here, and I'll give it name, let's say static example. Okay, so in Java there is a pre-existing library called lang. Within that we have a package called math that has so many mathematical functions. Suppose one of them that we'll use is the out of two integers finding the minimum or the maximum number. Okay, so suppose in this class I have two integers present, so let's say int a. Okay, and let's give it a value which has a value 10, and there is another integer int variable present which is equals to 40. Okay, so now I'll create main method, and within main I want to find out the number which is maximum out of these, or the biggest number out of these two number, or let's say the minimum. So I can use the pre-existing methods that are present in the Java library, and I don't have to create any object for it. I can directly use it as soon as I'll do the import. Okay, so I know the library where that maximum minimum function exists, so I'll just simply import it. While importing it, as I told you that these methods are static, so again you have to make a static import. So I'll use import static. Now the name of that library, so it's in the Java .lang. Okay, within that it's math, and within math the function that I want to import is, let's say, max. I wrote that function, and that is for the integers, you see here. Okay, now here I can directly use that method, no object, nothing. Directly call that method and use it. Just pass the integer values and it will give you the maximum value out of it, maximum, or let's say the minimum value out of it. Okay. Okay, so I didn't make those variables static. So again, I have to make those variables static. If I do not want to make them static, again I have to use the object. I'll show you that process also. But this is the property of static methods, that you can only use the static variable inside a static method. Okay, so now if I'll run this in the output, I will see the number which is the maximum, and that is 40. Okay, now let's just discuss why we are earlier getting the error, because there was no static keyword. Okay, so now these are non-static variable and I'm trying to use this inside a static method, which is not possible. So if my variables are non-static, I can simply create the object of the class. So name of the class is this, give it an object reference, let's say obj equals to new static example. Okay, little mistake here. Now you're fine. I can use it now using the object, so I'll say obj.a, now it's fine, and obj.b. Now again if I'll run this, I'll get the right output. Okay, so I'll just copy this line and I'll show you what we did earlier. So earlier we were using like this if the variables were static. If they are non-static, just create their object and use it as it is. Okay, so this is how we work with the static. There are so many points, when we'll work with the rest assured libraries, we'll deal with the static method, so we should know it, how to make the import and how to use it. So these are the the few main points, that only static variables can be used inside a static method. A non-static variable can be used, but you have to create the object of it, right? The old why and when we create a method static, basically for the functionalities that should not be dependent on the object, okay, or the common functionality that is common among all the objects, or that is going to be used again and again. Okay, so for in these cases we make a method or a variable static. I hope it's clear to you now. Okay, so again, if you have any doubt from this session, you can write in the comment box below and will get back to you. If you like this video, subscribe to the channel for the more videos like this. Thank you.